So this question asks about the difference between a reversible and an irreversible process. So first, let's start by defining those two terms. A reversible process can be reversed by infinitesimal changes in some property of the system without any sort of entropy production. Because the changes are infinitesimal, the system is in equilibrium throughout the process, and so there is no heat production or no entropy production. On the other hand, an irreversible process cannot be perfectly restored to its initial state without expenditure of energy. This means that an irreversible process always increases the entropy of the universe. So using this information, we can go through each of these processes to determine whether they are reversible or irreversible. If we take the first one, a solid melting infinitesimally slowly at its melting point, we see that this is a reversible process because it occurs at a constant temperature. This is a phase change in which both phases are in equilibrium. So anytime there is a phase change that is happening at equilibrium, we know that it is reversible. So we can say that this is reversible. Similarly, anytime that there is a phase change that is happening infinitesimally slowly, we know that this is a reversible process because it occurs at a very infinitesimally slow pace without any entropy production. So the next process, liquid freezing infinitesimally slowly at its freezing point, is also reversible. And the next one, liquid vaporizing infinitesimally slowly at its boiling point, is also reversible. Gas condensing infinitesimally slowly at its condensation point is also reversible by the same logic. Now let's take a look at liquid freezing below its freezing point. Since this is not occurring at the freezing point but below it, we know that temperature is changing and therefore there must be an expenditure of energy. Also, this is not happening infinitesimally slowly, and so this cannot be a reversible process. Instead, this is an irreversible process. In the same way, liquid vaporizing above its boiling point is also irreversible, and gas condensing below its condensation point is irreversible. Now let's take a look at swinging of a pendulum. A single swing of a real pendulum is irreversible because there is friction involved in the pendulum, and thus this increases the entropy. So this is irreversible. You can think about it by thinking of an actual pendulum. So if I draw a pendulum here and we swing it, it will swing for a while, it'll go back and forth, but eventually it stops. And that's because there is some friction. If the pendulum was frictionless, it would continue to swing back and forth forever. And so that is reversible. So a single swing of a frictionless pendulum is a reversible process. The last one is a little tricky. It's solid melting infinitesimally slowly above its melting point. we know that anytime an object is not at the melting point or the boiling point, temperature is changing. And so this must be an irreversible process. It's only at the melting point and the boiling point where temperature is constant. And so, since temperature changes, even if it is infinitesimally slowly, this cannot be a reversible process without the expenditure of energy. And so, this is also irreversible.